Hello everyone, today we will do class 9th chapter 8th quadrilaterals exercise 8.2 question number 2. ABCD is a rhombus and P, Q, R and S are midpoints of sides AB, BC, CD and DA respectively. Show that the quadrilateral PQRS is a rectangle. So we have to prove that this quadrilateral PQRS is a rectangle. Now for that we have to first prove that it is a parallelogram. We will be proving first that PQRS is a parallelogram. So let us start. So we will start with in triangle ADC, S is midpoint of AD, R is midpoint of DC. Therefore, by midpoint theorem, SR is parallel to AC and SR is half of AC. Now this is a midpoint theorem. Line joining the midpoints of two sides of triangle is parallel to third side and is half of third side. So we will write in triangle ABC, P is midpoint of AB, Q is midpoint of BC. Therefore, by midpoint theorem, we have PQ is parallel to AC and PQ is half of AC. Let us take this as 2. Now from 1 and 2 we can see SR and PQ both are parallel to AC. So they will be parallel to each other. Similarly SR and PQ both are equal to AC. So SR and PQ are equal. So we can write from 1 and 2 SR is parallel to PQ and SR is equal to PQ. That is in quadrilateral PQRS, SR and PQ are parallel as well as equal. Now therefore PQRS is a parallelogram. If one pair of opposite side is parallel as well as equal, it is a parallelogram. Therefore PQRS is a parallelogram. Now we have to prove that this PQRS is a rectangle. Parallelogram we have proved PQRS is a parallelogram. Now we have to prove that it is a rectangle. Now ABCD is a rhombus. Let the diagonals AC and BD of rhombus intersect each other at O. Now we also know that diagonals of rhombus are perpendicular to each other. That is, this angle is 90 degree. Diagonals of rhombus are perpendicular to each other. Let us take this point as M and this point as N. Now we have PM parallel to NO as PQ is parallel to AC. This we have proved above that PQ is parallel to AC. Also, PN is parallel to MO as PS is parallel to BD. Again, PS will be parallel to BD as P is the midpoint of AB, S is the midpoint of AD. Line joining the midpoint of two sides of triangle is parallel to the third side. Now see here, PM is parallel to NO, PN is parallel to MO. That means this small quadrilateral is a parallelogram. Its opposite sides are parallel to each other. Therefore, quadrilateral PMON is a parallelogram. If it is a parallelogram, its opposite angles will be equal. That is, this angle will be equal to this angle. So we will write, therefore angle NPM is equal to angle NOM. Opposite angles of parallelogram are equal. Or we can write angle SPQ. If I am writing here NPM, this is same as SPQ. This is equal to NOM. But angle NOM is 90 degree. Diagonals of rhombus are perpendicular to each other. So therefore angle SPQ is 90 degree. Now that is PQRS is a parallelogram. Remember, we have first proved that it is a parallelogram in which one angle is 90 degree. That is, automatically all the angles will be 90 degree in the parallelogram. Opposite angles are equal. If this is 90, this will be 90 degree. Adjacent angles are supplementary. If this is 90, this will be 90 degree. So ultimately all the angles will be 90 degree. So PQRS is a parallelogram in which one angle is 90 degree. Therefore PQRS is a rectangle.